Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 22 of quantum mechanics, in which I'm going to discuss WKB method. Okay, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so I'm going to start. It is WKB method. Okay, and it is WKB means Wenzel Kramer Brillouin method. Okay, so it's a Brillouin. This is a French name, French scientist. Okay, so Wenzel Kramer's Brillouin method. Okay, which we are going to study. Okay, okay. So so WKB method. Okay, so before that, I'll just write about perturbation method, perturbation theory we have written, right? So I'll just give a brief idea about that as well. In perturbation, in perturbation, in perturbation theory, in perturbation theory, it is difficult. It is difficult. It is difficult to find out higher order energy corrections. Out higher order higher order higher order energy correction. Okay, so in perturbation theory it is difficult to find the higher order energy correction, so the calculation is very difficult, right? And also we have studied a variational method, right? So variational method variational method variational method variational method is only used for ground state energy. Okay, used for finding ground state energy, finding ground state energy. Okay, so in variational method we find we use variational method to find the ground state energy. Okay, Mm, and now WKB method, that is Wenzel Kramer's Brillouin method. Okay, so this is WKB method. In short, we say WKB. Okay, WKB method. WKB method is only used, so is only valid, is only valid, is only valid for slowly slowly varying slowly varying potential, slowly varying potential, or for small wavelength, or for small wavelength. Okay, so WKB method is only valid for slowly varying potential. Slowly varying potential means that the potential is almost constant. Okay, or for a small wavelength we use WKB method. Okay, Wenzel Kramer Brillouin method. Okay, okay. So I'll solve the Schrodinger equation, that is time independent Schrodinger equation for this method. Okay, so we know that time independent Schrodinger equation, right? So that is del square psi upon del x square plus 2m upon h cut square, okay, E minus p psi equal to 0. This is the Schrodinger time independent equation, okay. So now from here we can write del square psi upon del x square plus k square psi equal to 0, where value of k is 2m e minus v 2m e minus v upon h cut square, okay. This is the value of k. This value is k, okay. Now we'll solve it, and we have done this work many times in quantum mechanics, right? So this is the 22nd lecture of the quantum mechanics. So in a simple harmonic oscillator, infinite potential box, rectangular potential barrier, and in many cases we have used it and find the solution, right? So now I'll write directly. So this is psi, the value of psi x is going to be simple. We'll get the auxiliary equation, right? And auxiliary equation, I'm going to do it for you as well. Auxiliary equation is going to be m square plus k square equal to 0. That implies value of m are going to be plus minus k, okay. So plus minus iota k, okay, iota k. So then the value of psi x is going to be psi x is going to be k e to the power iota kx plus b e to the power minus iota kx. This is the wave function, okay. And since we know px momentum is h cut k which is function of x, right? So px, or from here we can find value of k. K is the function of x, guys. So I'm directly writing k. So k is going to be px upon h cut, right? Px upon h cut. So here we'll put the value of kx, okay. So this is psi x is going to be a e to the power iota upon h cut integration px dx, okay. We can write this like, because we know if you integrate it, right, px dx is going to be px upon h cut, right? And this is the value of k, px upon h cut. So iota is here, right? Iota kx, right? So px upon h cut, right? So this if you solve this value is going to be iota h cut px upon iota, this is iota h cut into pxx, right? And value of k is px upon h cut, right? Then this value is going to be the same as iota kx, right? Similarly here it will be e to the power minus iota upon h cut, where we are putting the value of k, okay. So this is integration px dx, okay. This one will simplify it further. So psi x is going to be this is the one. Now psi x is going to be 1 upon root px square, or 1 upon root px. This is the momentum in x direction, okay. So this is going to be a e to the power iota alpha, okay, plus b e to the power minus iota alpha. This complete value, let's say it's alpha, okay, alpha. Yeah, this is the value. This is this we have got after normalization, okay, after normalization. after normalization. Okay, welcome. So value of alpha is here, alpha equal to uh, 1 upon h cut, okay, integration px dx. Okay, so this is the value. So instead of that we have put alpha. Okay, this is the value. Okay, so then this value is a e to the power I alpha plus b e to the power minus iota alpha. Okay, and this value we have got after normalization of the wave function. Right. So this value is going to be psi x is going to be 1 upon root px. So this is the function of x, right? So 1 upon root px. This is a. We will open it. Okay, so e to the power I alpha equal to sin alpha. Sorry, cos alpha plus iota sin alpha, right? A cos alpha x. Okay, alpha x. So these are function of alpha x. Okay, so alpha x plus iota sin alpha x. Okay, plus b, and this is going to be b e to the power iota alpha is going to be, it is going to be cos alpha x minus iota sin alpha x. Okay, so this value is going to be psi x is going to be 1 upon root 1 upon root px. Okay, into we can write a plus b cos alpha. Okay, plus this is going to be a minus b. We have just simplified it. Okay, a minus b sin alpha. Okay, sin alpha. Here we have mistake, done mistake, right? So this is just this one. Okay, this is just cos alpha iota sin alpha. Okay, and this is cos alpha iota sin alpha. Okay, because this is e to the power iota alpha. Okay, so then this value psi x is going to be this one, this complete values, this a plus b, we can consider this is like this one. Okay, 1 upon root px, and this value we can say this this is c sin beta. Okay, into cos alpha, and this value we can say plus c cos beta. Okay, c cos beta sin alpha. This a minus b is c cos beta, and a plus b is c sin beta. Okay, this one. So psi x value is going to be psi x value is going to be this one. C will take common, right? C upon root px, and this is going to be sin alpha plus beta, because this value is sin a cos sin alpha plus beta. Okay, this is the value of wave function, guys. Okay, from here, okay, just let me check whether I'm audible or not, guys. Okay, just let me check it first. and this value we can say this.
Yes,
This is
okay. So I'll start. Just give me 1 second, guys. Okay. Okay. So this is going to be this is total phase here. Total phase is alpha plus beta. Okay. Total phase is alpha plus beta, and where alpha value I have already told, that is 1 upon h cut integration px dx, right? Px dx. Okay. Now here total phase is a plus b. Okay. This is the total phase. So this is the value of waveform. Okay, in WKB approximation. And now there are two conditions which I'll write. If potential at classical point, I'll solve questions, then it is going to clear your all doubts. Okay. If potential at classical turning point, if potential at classical turning point is number 1 is infinite. Okay, if potential at classical turning point is infinite, okay, infinite, in that case value of beta is going to be 0. Okay, if potential at classical turning point, so I'll solve question. Okay, then it will be more clear to you. So if potential at classical turning point is number 1 case is if infinite, then value of beta is going to be 0, and second case, this is case 1. Okay, and this is case 2. Okay, so if it is finite, okay, if it is finite, then value of beta is going to be pi by 4. Very important point, right? Okay, note down and memorize it. Okay, next, very important condition which I'm going to write now. Okay, which will help you to solve questions. Okay, so you can easily solve by that condition, that is quantization condition for WKB method. Okay, quantization condition for WKB method. Okay, WKB method means Wenzel Kramer's Brouin method. Okay, this is a French name. Okay, so quantization condition for WKB method. Okay, so that is alpha 1 plus beta 1, okay, plus alpha 2 plus beta 2. Okay, this value is going to be n pi. Okay, and here n starts with 1, 2, 3 and so on. Okay, we'll put the value. So this is going to be 1 upon h cut integration alpha value we know, right? That is px dx. Okay, and this is minus a to a plus minus a to x, guys. We have taken 1 point x plus 1 upon h cut integration alpha 1 alpha 2 value we are putting x to a px dx plus beta 1 plus beta 2 equal to 0. Okay, this is beta 1 plus beta 2 equal to 0. Okay, so this is the condition, right? 1 upon h cut minus a to x p dx px dx, and 1 upon h cut x to a px dx plus beta. These are alpha 1 alpha 2 value, and these are beta 1 plus beta 2. This condition is going to be n pi, guys. Okay, n pi. So this is n pi. Very important condition. We'll solve questions using this condition. Okay, and value of n I have already told. The value of n is 1, 2, 3, so on. Okay. Okay, guys. So this is the quantization condition for WKB method. Now I'll solve questions, and then it will clear your all doubts. Okay. Okay. So question is find energy eigenvalue. Find energy eigenvalue. Find energy eigenvalues. Energy eigenvalues of energy eigenvalues of 1D infinite 1D infinite potential box, 1D infinite potential box, 1D infinite potential box of size L using WKB method. That is Wenzel-Kramer's Driva method. Okay. So this is the find energy eigenvalues of 1D infinite potential box of size L using WKB method, right? We know this. I have already explained the energy eigenvalue of 1D harmonic oscillator. Oh, sorry, 1D infinite potential box, right? Here we are going to get that energy eigenvalue En with the help of WKB method. Okay, Wenzel-Kramer's Driva method. Okay. Okay. So I'll solve this question with this method. Okay, so this is the potential box, guys. Infinite potential box, 1D infinite potential box, and the size is 0 to L. Okay, and we know the potential is 0. Okay, between 0 to L, else it is infinite. Okay, so this is the 1D infinite potential box. Okay, this is the potential, and this is the size is L, that is 0 to L. Okay, now what are the classical turning point, guys? Classical turning points classical turning points are 0 and L. Okay, these are the classical turning points. So I have already written the condition, right? If if the potential at classical turning point is infinite, then beta value is 0. If finite, then beta value is pi by 4. So here classical turning points which are 0 and L. So these are the classical turning point. At this point we can see the potential is infinite. Okay, but between this point is potential is V, that is 0. So classical turning points, that is 0 and L, okay, lies at infinite potential. Okay, infinite potential, right? So we can see at 0 potential is infinite, as L 0 potential is infinite. So classical turning point 0L lies at infinite potential. Okay, so this implies and we know if that is the case, beta equal to 0, right? Beta equal to 0 means here beta 1 equal to beta 2 equal to 0 for this condition. Okay, beta 1 and beta 2 is 0. okay, value. So now we'll solve it. Okay, so here we know since Px, so this is we'll write this condition. Okay, integrate, so 1 upon h cut integration 0 to x Px dx plus x to L, because this is between 0 to L, right? 0 to x we have taken any point, so 0 to L Px dx, 0 to L Px dx plus beta 1 beta 2, right? This condition beta 1 beta 2, and this value is 0. 0 plus 0 equal to n pi. Okay, this is n pi. Now we'll write value of p. Okay, px, right? Value of px is going to be this is going to be root 2m e minus v, 2m e minus v. Okay, since v equal to 0, this is given, right? V equal to 0, so value of px is going to be root 2 me. Okay, this is the value of this. So now we'll put the value in this equation. Okay, with this equation we can write 1 upon h cut, this integration 0 to x and 0 to L, right? So we can combine and we can write integration 0 to L. So this is 0 to L, and value is p dx, right? P dx, px dx, px value is this one. So this is px value, right? So root 2 me, root 2 me, root 2 me dx equal to n pi. Okay, so how we got this value, guys? This we know, because since we know px square upon 2m equal to e minus p, right? Total energy, this one, e equal to px square upon 2m plus b, right? From here we've got the value of px, right? So this value is this. V is 0, so this is this, then the value is going to be 1 upon h cut integration 0 to L yeah 0 to px, right? Root 2 me dx equal to n pi, right? And so this value is going to be 1 upon h cut, 1 upon h cut, root 2 me is constant, we have taken outside, and this integration is going to be x 0 to L equal to n pi. So from here the value is going to be 1 upon h cut root 2 me, and this value is 0 to L, right? L equal to n pi. We'll square both sides, squaring both sides, so this is going to be 2 me upon h cut square is going to be n square pi square, right? So from here value of e is going to be, and this is L square, guys. Okay, L is also there, L square, so this is going to be n square pi square h cut square upon 2m L square. Okay, so this is the energy eigenvalue which we have already got in 1D infinite potential box, right? So this is the energy eigenvalue, and this we have found by WKB method, right? This is the WKB method. and these are the classical points, and this is the quantization condition we have put, and then we have simplified value of Px we have got from here, because total energy is kinetic energy plus potential energy, right? So, and we have solved it and we got the energy eigenvalue. This is the energy eigenvalue of 1D infinite potential box, and we have find it by WKB method. Okay guys, and next question. Next question. Next question is, this is also a very good question. There are two questions we are going to solve one by one. The first one is this one. Okay, so this is 1D harmonic oscillator, right? And this is A, this is A, and this is minus A. These are the classical points for this 1D harmonic oscillator energy, full harmonic oscillator. Okay, second we have to find for this is half, this half part of the harmonic oscillator. Okay, so from here this is going to be A is the classical turning point, and this is 0. Okay, and energy we know, this energy we know, that is En. I have already explained it in the harmonic oscillator. This we know, n plus half h cut omega, n plus half into h cut omega, and this energy we know for half part of the harmonic oscillator, right? So the half energy, then this is going to be 2n plus 3 by 2 h cut omega. So these are the energy. Now we are going to find these values using WKB method. Okay, using WKB method. So I will solve this one by one. Okay, so this is the energy eigenvalue for the harmonic oscillator, complete harmonic oscillator. This is the energy eigenvalue of half part of the harmonic oscillator. Okay, this is the half part of the energy. Okay, so I'll start with this one. Okay, first one. So first one I'll make a diagram again. A minus A. Okay, this one. So here we know that E equal to Px square upon 2m plus Px square upon 2m plus, for this one dimensional harmonic oscillator, potential energy is half m omega square x square, right? So this is the E, and from here we can get value of Px, and that value is going to be root 2me minus m square omega square x square. Okay, from this equation, total energy I have found value of Px. Okay, so this is root 2me minus m square omega square x square, right? So this is the value of Px, right? So now we'll find out this value, this integration minus a to a for this harmonic oscillator. Okay, this is going to be minus a to a Px dx, right? Px dx, this value is going to be integration minus a to a and root 2me minus m square omega square x square dx, right? Or we can write this value, this is minus a to a Px dx, this is going to be, here you can see x square is here, right? This function is even function, guys, so we can break the limit, because x square is the variable, and that is whole square, so this value is always going to be positive, right? So we'll break the limit. So this is going to be 2 into 0 to a right? 2 into 0 to a, and root 2me minus m square omega square x square, okay? M square omega square x square dx, okay? So minus a to a, this value, right? This value is going to be, now we have to solve this integration, guys, and how we are going to solve it, that I'll tell you. So here we can put, so first we'll find at turning point, at classical turning point, at turning point at turning point, the total energy is equal to potential energy of the system, okay? So E equal to Vx, now we'll put the value, so E equal to half m omega square x square, right? From here value of x is going to be root 2e upon m omega square, okay? M omega square, okay? So so this is the value, right? So it means for x minimum and x maximum, and x maximum, okay? Value of x is this, right? This one, x is 2e upon m omega square, right? So uh, it means value of a is root 2e, because these are the point, right? 0 to a. X minimum is 0, x maximum is a. So value of a is 2e upon m omega square. 2e upon m omega square, right? Next. So here now we'll make some substitutions, okay? So let x equal to a sine theta we can put, okay, for making it simple, for integrating the expression, okay? So it means dx is going to be a cos theta d theta, right? And so a cos theta d theta, and limit also will change, right? Limit is this one minus this one, okay? Okay, here, right? So this is the ball, so this one, so this is going to be, so limit is going to be x dx, so limit, this is the limit, right? Okay, so this value is going to be integration minus a to a dx value is going to be limit, you can see limit, right? Limit is this one, 0 to a, right? So it is going to be, so limit will change, so limit is going to be like this. This is the value of x and theta, okay? So when x equal to 0, theta is also 0, because sine theta is 0, okay? When x equal to a, this one, when x equal to a, value of theta is going to be pi by 2, because a equal, this is a and a will get cancelled, sine theta equal to 1, right? It means theta equal to pi by 2, right? So these are the limits, so we'll change limits. So limit is going to be 0 to pi by 2, okay? And we'll put the value, so 2me will take common, okay? And this is going to be root a square minus x square dx, okay? This one, because we have made like this, and now we put the value, okay, of x in this expression here, okay? And value of, put the value of a as well, value of a is this, right? Value of a is this, so this implies value of a square is going to be 2e upon m omega m omega square, right? So if you put these values in this expression, right, so this is going to be 2me will take common as a constant, and this is going to be the value. Okay, so again we'll take this common, so this is going to be 2me. Okay, so here I'll do one thing. I'll put the value of a as well. So it is going to be integration 0 to pi. A will take common. Okay, this is going to 1 minus a equal to a sine theta, right? So a will take common. It is going to be root 1 minus cos square theta, 1 minus sine square theta, right? This will be cos theta, and dx value is into a cos d theta, right? So this is going to be 2ma square integration 0 to pi by 2, and this is going to be cos square theta d theta. Okay, so we'll solve it further. So this is going to be integration 0 to minus a to a px dx is going to be, this value is going to be this one, right? 2m a square to m here, 2m omega also will take common, so this is going to be 2m omega. So this is 2m a square, right? We'll put the value of a. So this is 2m a square. So 2m omega a square. Okay, so this is 2m omega, 2m omega. Okay, 2m omega a square, 2m omega a square, and this is going to be 0 to pi by 2. This and omega is also there. Okay, omega a square. So this is going to be this a square 0 to pi cos square theta. We can write 1 plus cos 2 theta by 2, right? Because d theta, because we know cos 2 theta equal to 2 cos square theta minus 1. So we have used this identity and we put the value. Okay, so this is going to be 2m omega a square. Okay, 2m omega a square, and this value we will integrate. So this is going to be pi by 2, 2 will get cancelled. Okay, pi by 2 minus this is sine 2 theta. Sine 2 theta means sine pi by 2, right? And pi by 2, this value is sine pi is 0. Okay, so this value is going to be 2 got cancelled. So m omega pi a square by m omega pi a square by m omega pi a square by 2. Okay, this is the value minus a to a px dx. Okay. Okay, so this is the value, and we will put the value of a as well. So m omega pi upon 2, and value of this is 2e upon m omega square. A value of a, right guys? I have already found this value of a is a square is 2e upon m omega square, right? So m omega square. So the terms will get cancelled, omega will get cancelled, and m will get cancelled, and this value is going to be e pi upon this m will get cancelled with this omega will get cancelled with omega times, right? 2 will get cancelled with this, so this is going to be e pi upon omega, right? Now we'll put, now we know, we can see, since both the both the boundaries are smooth, are smooth, both the boundaries are smooth. So it means both the boundaries are smooth. Okay, so this means this value minus a to a px dx, this value is going to be n plus half h cut pi. Okay, if both boundaries are smooth. Okay, so this both boundaries are smooth, these are smooth. Okay, so we'll put the value of this. Value of this we have already found, that is e pi upon omega, e pi upon omega equal to n plus half h cut pi. Okay, so from here pi will get cancelled and value of e is going to be n plus half h cut omega. Okay, so this is the answer. This is we already know, right? Now we have solved it by WKB method. Here I would like to write some, before solving another second one, I'll write something here which is important. Okay, so three condition. Okay, if both walls or boundaries are smooth, in that case uh, integration px dx is going to be this value is going to be n plus half h cut pi. Okay, n plus half h cut pi. Okay, this value is going to be n plus half h cut pi. Well, so this is the one. Or if n starts with 0 1 2 so on. Okay, if n starts with 0, like for if you talk about simple harmonic oscillator, right, here n starts with 0, but if you talk about infinite potential box, then n starts with 1. Okay, if and second is if n starts with 1, then px dx value is going to be uh, n minus half h cut pi. Okay, n minus half h cut pi, where n equal to 1 2 3 so on. Okay, similarly second one is if one wall is rigid. I'll solve question, then it will clear your doubt. Okay, it will be more clear to you. So if one wall is rigid and other is smooth. Okay, so in that case value of px dx is going to be n plus 3 by 4 n plus 3 by 4 h cut pi. Okay, n plus 3 by 4 h cut pi, and n are going to start with 0 1 2. Okay, and second one is if n starts if n starts with 0. If n starts with 1, then it is going to be px dx, that value is going to be uh, n minus 1 by 4 pi h cut. Okay, n minus 1 by 4 pi h cut. If n starts with 1 2 3 so on. Okay, if n starts with 1 3 1 2 3 so on. Okay, this is third case is if this is the both walls are smooth, right? And here if one wall is rigid and other is smooth, then this is the case for when n starts with 0. Okay, n plus 3 by 4 h cut phi, and this is p dx integration px dx is going to be n minus 1 by 4 pi h cut, then n starts with 1 2 3 4. Okay, this is the one. Now case third is, these are very important points, right? Okay, so case third is this is the case third if both walls are rigid. Okay, if both walls are rigid, that will be the first case we have solved, right? That is the infinite potential box. Both walls are rigid here, right? Because these are the infinite box, infinite, and these walls are rigid. Okay, both walls are rigid. In that case, the value of px dx is going to be, value of px is dx is going to be this is n plus 1 pi h cut. Okay, n plus 1 pi h cut if, or we can write first n pi h cut. Okay, n pi h cut. Okay, it is n pi h cut. Okay, where n starts with 0 1 2 so on. Sorry, n starts with 1 2 3 4. 0 is not there. Okay, so 1, this is 1 2 3 so on. Okay, and this value px dx is n plus 1 pi h cut if n starts with, this is case of harmonic oscillator, and this is the case of 1D potential box. Okay, infinite 1D potential box. So this will start with 0 1 2 3 so on. Okay, so these are the different, so this is the both walls are rigid. Okay, then n pi h cut for the when n starts with 1 2, and n plus 1 pi h cut when it starts with 0. And in this case, if both walls are rigid, one is rigid, one other is smooth, then pdx values for one rigid, one this is going to be n plus 3 by 4 h cut phi, right? And n will start here with 0. And similarly, if if n starts with 1, then n minus 1 by 4 pi h cut. Okay, and for this case, right, if both boundaries are smooth, then for when n starts with 0 1 2, then n plus half h cut phi, and if it it starts with n equal to 1 2 3, then px dx integration value is n minus half h cut phi. Okay, so this is very important. Okay, so now I'm going to solve next part of this question. Okay, so this is for half of the energy of the half harmonic oscillator, half part of the harmonic oscillator. Okay, this one. So for this case, we know this is a and this is 0. Okay, got it. So for this also we know the total energy. Total energy is px square upon 2m, px square upon 2m. Okay, and plus half m omega square x square, right? Right, and so now from here we can get the value of px. Px value is 2me minus 2me minus half m square omega square x square, right? From here we can get this value, and then simple integration 0 to a px dx is going to be this is simple, that is we'll put the value directly, okay, and this is going to be m omega 0 to a. Now the value will be between 0 to a, right? M omega 0 to a and a square cos square theta d theta, right? We have already explained the limit and everything there. X equal to, we have put a sin theta, and from here dx value is a cos theta d theta, right? And limits are going to be, if x equal to x and theta, if x equal to 0, theta equal to 0, right? If x equal to a, sorry, if x equal to yeah, x equal to 0, x equal to a, then the value of this is a, okay, x equal to a, then value of this is 5 by 2, theta is 5 by 2, right? And from here the value is this, I have already explained in my same question I have solved, 0 to 5 by 2, right? This one. Now simple thing, m omega now will solve it, and this value is going to be cos square value, right? So this is going to be m omega square a square upon 2, right? And this value is 0 to pi by 2, and cos square is 1 plus cos 2 theta d theta, okay. Well, so this is the one, and now we'll put the value. So value of 0 to a px dx is going to be n omega a square upon 2 into pi by 2 plus 0. Simple integration, this value is going to be pi by 2, this value is going to be 0, sin theta sin pi equal to 0, right? So this value is going to be m omega pi by 4, a square value will put, that is 2e upon 4 h cut. Here also I have already explained this one, right? Turning point at turning point, I'll write here, at turning point equal to vx, so equal to half m omega square x square. So from here value of x is going to be 2e upon m omega, and that is the value of a, right? I've already explained this, so that is root 2e upon m omega, okay. So from here we can also get value of a square, that is 2e upon m omega. So here we'll put the value 2e upon m omega square, 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 right? So m omega square, and this value is going to be e pi e upon 2 omega, okay. So now we can see this, one wall is rigid and one wall is smooth, right? So we know, since one wall is rigid and other is smooth, this implies 0 to a px dx, this value is going to be n plus 3 by 4 pi h cut, right? This one I have already explained this one. If one wall is rigid and other is small, then this value is n plus 3 by 4 h cut pi, right? So this is going to be n plus 3 by 4 h cut pi, right? Because here n is starting with 0, right? That's why this value. So this value is going to be, this value we know, we have already explained, it is pi upon 2 omega, right? So this is going to be pi e upon 2 omega, pi e upon 2 omega, this is going to be n plus 3 by 4 pi h cut. So this value is going to be, pi will get cancelled, omega will go there, 2 will go there, so value of e is going to be 2n plus 3 by 2 h cut omega. Okay, so this is the value for this, if for half part of the harmonic oscillator. Okay, so this is the one. Next one is, so there are some tricks which I will tell you, because by that you can solve all the questions from WKB and quickly. Okay, else if you else there is huge integration, the integration is very complicated, and then it will be tough for you to solve questions. Okay, so I'll tell you the trick, and that trick is going to help you, and you can easily solve 5 marks question within a minute by the trick which I'm going to explain to you. Okay, well, so here now we know two things, right? That is this I have already explained, right? So here I'm going to write, this is 1 upon h cut, this one. So this is the one. Okay, so trick I'm going to explain. Trick. So you can solve those questions very quickly. Okay, so first understand, on this trick is only applicable when both classical turning point, both classical both classical turning point both classical turning both classical turning point both classical turning points both this okay, only applicable when both classical turning points are finite. Okay, and turning points lies at finite potential. Okay, at finite potential. Okay, so this trick is applicable only when classical turning point lies at finite potential. Okay, so they are not lies only in finite potential. Okay, they lies at finite potential. Okay, so for example, if we have been given Vx, value of Vx equal to given C x to the power m. Okay, C x to the power m is given, then we can easily found value of En. En is going to be proportional to n, and the relation between En and is going to be, En is going to be proportional to n, that is then it's equal to n to the power 2m upon m plus 2. Very important, guys. Okay, easily you will solve questions. M plus 2, 2m into m plus 2, 2m upon m plus 2. Okay, so En is going to be is proportional to n to the power 2m plus 2m upon m plus 1, where m is power of x. Okay, suppose if it is m equal to 1, okay, m equal to 6, suppose m equal to 6, then in that case n value is going to be proportional to n into 2 into 6 upon m plus 1, right? And means 6 plus 2, so this is 12 upon 8. So this is going to be proportional to e to the power 12 upon 8, right? 4 3 by 2, because 12 1 upon 8 will cancel by 4. 4 3 is 12 and 4 2 is 8, right? E to the power 3. So En is proportional to n to the power 3 by 2. This is how we can easily solve it, okay, in questions. So very important formula. I'll explain it by giving example. Okay, I'll solve questions. So this is the one, and also En is proportional to c to the power, c is the constant, okay, c to the power 2 upon m plus 2, okay, c to the power 2 upon m plus 2, c is the constant, okay. Suppose like this, Vx we know, right, half m omega square x square, right? So we can write like this, Vx equal to cx square, because this part is constant, right? So if this is the potential given, then En is going to be proportional to c to the power m values 2 is the value, right? So 2 upon m plus 2, 2 plus 2, so proportional to c to the power 1 by 2, right, in this way. So this is these are two tricks, okay. So you can easily find this n and c, that proportional, that n is proportional to this, and En is proportional to n like this, and En is proportional to c like this, okay. Very important, you need to note down and memorize it, guys, very important. Next trick is, if you have to directly find the value, okay. So En, you have to find the value of En. So if you if you have to find value of En, right? So for WKB method, you will get very complex integration, right? And it's very tough to solve those integration. But if you know this trick, you can easily find the value. And how you will find? So what you need to note down and memorize, I'm telling you, okay, by trick. So value of En is going to be c, which is constant, and this is n plus half h cut, n plus half h cut root pi upon 2mc, root pi upon 2mc, okay, and then gamma 1 upon m plus 3 by 2, 1 upon m plus 3 by 2 upon gamma 1 upon m plus 1, gamma 1 upon m plus 1, and this whole to the power 2m upon m plus 2, okay. And the condition is here, n starts with where n starts with 0, okay, n starts with 0 1 2, okay, this one, and value of En. So if you put this value here, you can easily find out the value of energy eigenvalue, and this is c, if n equal to, n starts with 1, okay, c n minus 1, n minus half h cut, n minus half h cut, Cn equal to n minus half h cut root pi upon 2mc, root pi upon 2mc, root pi upon 2mc, gamma 1 upon m plus 3 by 2, gamma 1 upon m plus 3 by 2 upon gamma 1 upon m plus 1 whole to the power 2m upon m plus 2, okay. Here m starts with, where n starts with, where, very important, okay, where n starts with 1 2 3. If n starts with 1 2 3, then this En value is c into n minus half h cut, okay. Everything is same, n minus half h cut, okay, n minus half h cut root pi upon 2mc into gamma 1 plus m plus 3 by 2 and gamma 1 plus m plus 1, okay. And if n starts with 0, then c n plus half h cut root pi upon 2mc and gamma 1 upon m plus 3 by 2 upon gamma 1 upon m plus 1 whole to the power 2m upon m plus 2. Okay, so this is the trick, guys. Okay, you need to note down. Very important, guys. Very important. Now I will give one example so that you can easily understand this trick. Okay, how to get it. So for this one, for bx is given question, example and question. Okay, this is question. This is a question as an example. Okay, so this is we have given vx equal to half m omega square x square. Okay, okay, this is given and we need to find out the value of en, right? We have found the value of en, right, by WKB method, and that was the lengthy there is a complex that integration, right? So there are very tough integration you will get from the you need to solve from WKB method, right? But if you know the trick, you can easily solve it. For vx is given like this. Okay, so vx we can write it in this form. This is c x to the power 2, right? C is where c is half m omega square, right? We can write like this. If this is the case, now c is given and x is x to the power m, right? X where m is 2. Now easily we can find out by this trick. En is going to be by this trick, and here n starts with 0 1 2, right? Because it's a harmonic oscillator. So for n is, when n starts with 0 1, then 0 1 2, then this trick will use c n plus half root pi upon 2 mc gamma 1 upon m plus 3 by 2 upon gamma 1 upon m plus 1 whole to the power 2m upon m plus 2. Okay, so here n is 2. So we'll write c n plus half h cut n plus half h cut. Okay, n plus half h cut and root pi upon 2mc pi upon 2mc. Okay, and gamma 1 upon m plus 3 by 2 upon gamma 1 upon m plus 1 whole to the power 2m upon m plus 2. Now m value is 2, right? So we'll write En is going to be, C value we also know. C value is this, half m omega square, right? Half m omega square value of C. This is value of C. N plus half. This is going to be n plus half h cut root pi upon 2mc. C value is half m omega square, right? Into gamma 1 upon m means 1 upon 2 plus 3 by 2 upon gamma 1 upon m means 1 upon 2 plus 1. Okay, whole to the power 2m means 2 into 2 upon m plus 2. M means 2 plus 2. Okay, so 2 this is 4 by 4 means 1, right? So this is going to be, En is going to be. So these questions I would suggest you guys, very lengthy questions. If you will in examination, if you will start solve, then you will get complicated integration, and it will consume lot of time, and your lot of time will get wasted, and you may not be able to solve that. So if you know this trick, you can easily solve questions related to WKB method in a minute, guys, right? And these are 5 marks questions. So En is going to be half m omega square, and this is n plus half n plus half and root pi upon, this is 2 will get cancelled, and this is m omega m square omega square, and root will remove the root, so this is m omega. Okay, and this is going to be half, or this is 4 by 4 means gamma 2. This value is gamma 2 upon this value is gamma 3 by 2, right? and this is power 1 because 2 to the 4 upon 4, 2 to 4, right? This is 1. So this is going to be half m omega square and n plus half h cut, right? N plus half h cut, and this value is root pi upon m omega, and gamma 2 is n, we know gamma n factorial, gamma n is n minus 1 factorial, right? This, no, we know gamma. So for that, the gamma 2 is going to be 1 factorial upon gamma 3 by 2 is 1 by 2 into root pi. Root pi will get cancelled, 2 will get cancelled with this, okay, and m will get cancelled with this, omega will get cancelled with this, right? So value of En is going to be n plus half h cut omega. Now see how quickly we have solved this value of En, right? Energy eigenvalue half half n plus half h cut omega, right? By the trick. We have also solved with proper method, right? And that took time. With complicated integration we have solved it, but now look how quickly we have solved it, right? This is En equal to n plus half h cut omega. I hope you understood it, guys. Okay, next question. This is the trick, guys, you need to note down. So now there's a question I would solve for you. So question is, Vx is given gx to the power 6. Okay, so here 6 here, so now we need to find out value of En. Okay, so here m value is x to the power 6, means m value is 6, right? So m is 6, so we can easily find relation between En and n, right? So it is going to be En n proportional to 2m plus m plus 2 2m upon m plus 2, right? This trick I have mentioned earlier, m plus 2. So this is going to be En going to be proportional to n to the power 2 into 6 upon 6 plus 2, right? So En is going to be proportional to n to the power 12 upon 8, right? So this is going to be En is going to be proportional to n to the power 3 by 2. Okay, very important, very simple question. Similarly, next one more question here. This is Vx is given gx, right? Means x to the power mod x, right? X to the power 1. So here m equal to 1. So En is going to be proportional to n to the power 2 into 1 upon 1 plus 2, right? So En is going to be proportional to n to the power 2 by 3. Okay, very simple. Okay, guys, so these tricks are very important. I would suggest you practice these questions and other questions as well using the trick, and memorize the trick, guys. Very important, and you can easily solve WKB related questions within a minute by using trick in your examination, and those questions are of 5 marks question, guys. Okay, well, so guys, before stopping, I'm going to stop here, but before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the examinations related to physical science. Okay, guys, thank you so much. Bye now.